All right, everyone, I think we're going to go ahead and get started here. So first off, I want to welcome you to today's webinar on 4 important Azure IaaS features for building your hybrid cloud. My name is Andy Syrewicze from Altaro Software, and I'm joined today by Aidan Finn. How's it going, Aidan?
Hey Andy, how are you doing?
Good, good. Hey, appreciate you taking the time to come and teach us about Azure today. It looks like a lot of great content.
Thanks for having me on. Hopefully everyone's going to enjoy this.
Yeah, not a problem. Always happy to have you here. So first thing I want to do is I want to talk about our agenda for the webinar today. So got a lot of great stuff lined up for you here. And next slide, please. There we go. So the first thing we're going to do is we're going to do some introductions of Aidan, myself, and Altaro Software. And then we're going to hand things over to Aidan for the bulk of the presentation today. He's going to talk about how options in IT are a good thing. Then going to talk about Azure Compute, storage, connectivity into Azure, Azure Resource Manager, and at the end we'll have the Q&A and wrap up. Now, real quick on the Q&A, feel free to ask your questions throughout the webinar today, and if Aidan has time to answer them as we're going through the content, we'll do so. Otherwise, we'll wait until the end during our Q&A section and we'll answer them there. With that said, though, it's rare that we have enough time to get through all the questions that we get on these webinars. So we always do a follow-up post out on our Altaro blog that contains a copy of the webinar, a recording. It contains the slide deck, and it also contains a full list of all the questions and their associated answers. So if you ask a question today that you don't get an answer for, be sure to check out for that follow-up post, and your question and its answer will be contained in there. So with that, I'm going to hand it over to Aidan so he can introduce himself, and we'll go from there.
Thanks, Andy. So I'm a MVP and technical sales lead with a company called Micro Warehouse in Dublin. We're a wholesaler or distributor of Microsoft and other technologies. So where that comes into play with Azure is that we're a CSP distributor. So that means we sell Microsoft cloud services to Microsoft partners who then sell them on to business customers. So I've been working and evangelizing with Microsoft Azure for the last 3 years, running training courses for salespeople and technical people, doing a lot of writing about Azure as well. I've been an MVP now. This is my 10th year. For the last 9 years, I've had the cloud and data center management or Hyper-V expertise, and a couple of weeks ago I was awarded with the Microsoft Azure expertise as well. I blog on aidanfinn.com, and I'm the contributing editor on Microsoft Virtualization for Petri.com. You can find me on aidanfinn.com on Facebook, but you're more likely to see me active on Twitter as @Joe_Elway.
All right, thanks, Aidan. Real quick about me, again, my name is Andy Syrewicze. I work for Altaro as a technical evangelist. I'm also an MVP in the Microsoft Cloud and Data Center Management competency, and I've been around the industry for a while now, going on 15 years. It's hard to believe, but during my time, I've spent a lot of time working for internal IT departments, managed services providers across all kinds of industry verticals. So if you run across something, I've probably seen it in some way, shape, or form. My main focus has always been in virtualization, cloud services, and the Microsoft server stack, with an emphasis on Hyper-V and VMware. If you're a Twitter person, I am out on Twitter at @asyrewicze. I really should have found a handle that was easier to spell, but that's what I went with. Otherwise, I'm out on the Altaro blog, altaro.com/hyper-v and /VMware. So if you have any questions, you can always reach out to me there, and I'll be sure to get back to you. So with that, I'd like to talk a little bit about the sponsor of today's webinar, Altaro Software, again, the company that I work for. And Altaro is a fast-growing developer of some pretty awesome backup software. It's designed specifically for the SMB and the mid-market spaces, and for service providers that are supporting businesses in those spaces. Our virtual backup solution is called Altaro VM Backup. It's trusted by 30,000 plus customers and 6,000 plus partners and MSPs worldwide. And if you're interested in taking a look at that product, you can go out to altaro.com/VM-backup for more information. So with that, I'll hand it over to Aidan, and he's going to teach us about Azure. Take it away, my friend.
Cool, thanks, Andy. So I'm of the opinion that choice is a good thing. So sometimes I'm a bit frustrated when I go to a technical event or read some media or something that says, well, there's only one choice today, and that's to put everything in the cloud. So you go to an AWS event, Google event, read, one of the Sunday business newspapers, or go onto some certain blogs or podcasts, and you're just told, yeah, don't worry about that, insider preview for Windows Server. That's dead technology. You need to be in the cloud. That frustrates me because that's not what I believe. It's not what my resellers believe or their customers believe. And luckily enough, it's not what Microsoft believes. Microsoft, if you actually listen to, not their salespeople because they have sales targets, but when you listen to some of the people from Microsoft headquarters and when they're talking at some of the big conferences like Ignite or Inspire or something like that, they talk about these three different or parts of the cloud or that make up the Microsoft Cloud OS story. So you got what's running on the customer site. Whether you're running VMware or Hyper-V virtualization, or you're running cloud in the new Azure Stack, which is available to order since last week and shipping in September, then that's good. That's one part of the solution. Then you've got what service providers or hosting companies can offer. So they can build up great solutions on things like Windows Azure Pack or Hyper-V and sell them to those customers. Maybe it's, this bespoke hardware or scale or the certain engineering skills that they can offer. They're adding extra options for that customer. And Microsoft have their own public cloud services like Office 365, like EMS, CRM 365, and Microsoft Azure. And this extends those other alternatives. And Microsoft will say, well, use one of those, or two of those, or three of those. This is the important thing here is it's not where we work, it's how we work. And we work with one consistent platform. All of this is glued together by, well, a couple of things. We have consistent identity through Active Directory and Azure Active Directory. Azure Active Directory is able to synchronize our on-premise ID into the cloud and then extend that into over 3,000 Microsoft and third-party cloud services using industry standard protocols. We also have the consistency of Hyper-V across all of this. Now, don't worry if you're a VMware customer because Microsoft have a lot to offer there. And in fact, some of their cloud solutions in Azure will build upon VMware first before they build on Hyper-V. So Microsoft has just realized there's a bigger market out there with VMware customers. So we have a lot of options, and Microsoft are giving us the choice to pick what's the right way to deploy our line of business applications. Where's the right place to deploy our services and our data? This is a hybrid cloud solution, and a hybrid cloud is way more than just setting up a network connection. Anyone can set up a VPN connection between a firewall and some edge device in a cloud. That's nothing. It's more than just that. It's having integrated identity, the ability to do much more. Maybe I want to run my systems management from the cloud, like I can with Operations Management Suite in Azure. And I can suck in data from my on-premise VMware, from my AWS deployment, and manage and monitor my environment, monitor best practices, do security auditing, do network level inspections, and be able to see everything in one central place. Maybe it's I want to collaborate in Office 365 using Teams or Office Groups. If you haven't heard of Office Groups, seriously, you got to go look at Office Groups. There's just so many different things. Maybe you want to extend your backup. So stick around to hear what Andy has to say about that at the end of the session. Or maybe it's disaster recovery. You're running production systems on Hyper-V or VMware and you'd like to have a DR site and you've never been able to afford it before. Well, have a look what Azure can offer. And it builds on a lot of what I'm actually going to be talking about today. So the first of these things I'm going to talk about is Azure Compute. So Hyper-V, imagine that you could take Hyper-V and run it on millions of hosts around the world. A few years ago, we heard that Microsoft was actually using 1 million Hyper-V hosts in Azure. And that was about 3 or 4 years ago. I wouldn't be surprised if it's multiples of that at this point, because Azure now is running in 40 regions around the world. Now, each of those regions is multiple data centers, and there's probably tens of thousands of individual servers in one of those data centers. Those Hyper-V hosts are organized into clusters or failover clusters of about 1,000 nodes each. Imagine that, a Hyper-V cluster that's 1,000 nodes. The max we can do on-prem is 64. Now, if someone says to you, Hyper-V just can't scale, smack them on the back of the head, point them at Azure and say, That's Azure. In fact, that's the same Azure that we can run on-prem. In fact, a lot of it is even a little older than we'll run on-prem. It's Hyper-V running on Nano server even. Most of it at this point is running 2012 and 2012 R2, although some 2016 has been introduced, as we'll mention later on in the session. So it is Hyper-V, but obviously it's doing a lot more things than we can do with Hyper-V on-prem. And that's because Azure is building this huge management system on top of Hyper-V. We'll talk a little bit about that later on as well. Now, there are some differences. You'll see that the Hyper-V in Azure is running Generation 1 virtual machines only. It's only using VHD format. It's not using VHDX. Yes, it does fail over. So if a host fails, the virtual machines will fail over and start up on another host in the cluster. But there's no live migration, because this is designed to be operated at cloud scales, not even data center scales, but way beyond what the large Fortune 1000s would be doing. This is one of the 3 biggest clouds on the planet. You're talking about scales that just boggle your mind. When you walk around one of these regions, and I've had the privilege of doing that, and I can't say much about it because I have to sign out 6 NDAs to do it, but when you do walk around one of those regions, it is just truly inspiring about how different it is and how much thought they've put through into every single piece of hardware that you see in there. Now, the fundamentals of what we're talking about are the same as they would be on-prem. A virtual machine is, in the end, made up of metadata and virtual hard disks. The metadata describes, the CPUs, the amount of memory, the disks, and what they're attached to. And then the disks themselves are files. They're virtual hard disks, fixed VHDs, not even dynamic VHDs. They're fixed VHDs for performance. And that's where your operating system, your applications, your settings, and your data are. Everything of value is in that VHD. The metadata itself, which is often just referred to as the virtual machine, is actually kind of worthless. The thing that's of value is that virtual hard disk. Let's talk a bit about the architecture of a virtual machine, because when you start getting into Azure, some of this can be a little confusing, especially when you start looking at some of the pricing pages from Microsoft or the pricing tools. They'll talk about a virtual machine having a disk size of 20 gigs, and you look at it and go, okay, I can see how that runs Linux. And by the way, something like 40% of the virtual machines running in Azure right now are running Linux. And today, 60% of the new deployments are Linux. There's a slew of Linuxes that are supported by Azure. This is a whole new Microsoft, lots of open source and non-Microsoft stuff in there. But when you look at that virtual machine, it says 26 or 20 gig disk size. Geez, I'm not going to run too much Windows on that. And that's true, you're not, because that's actually not the size of the disk. That's actually the size of the temp disk. That temp disk that you see attached to the virtual machine is stored on the host's internal storage. It's not on some back-end storage. And the reason it's on that internal storage on the host is because it gives low latency connectivity. And that gives you a clue as to the use of the temp disk. It's used to store the paging file for the guest OS of the virtual machine, which means when the virtual machine is paging in and out memory, it's able to do that very, very quickly. And all but the lower spec virtual machines are using SSD for that temp drive. So the 2 lower spec virtual machines are storing their temp DB on HDD, but every other virtual machine is storing that temp drive on SSD, which means paging is really fast. And there's also some cool stuff we can do with that. So if you're running SQL Server in the virtual machine, you can move temp DB onto that temp drive. Now, you shouldn't store anything else on there. That is really only a caching drive. And there's a clue to that when you browse that D drive or that E drive, depending on how the virtual machine was deployed. There is a text file in there, and if you open up and read it, it's actually in English and I believe Chinese, though I don't read Chinese, so I'm not 100% sure. But basically, and I'm going to paraphrase this, it says, if you store data on here, prepare to be fired. And that's the way to think of it, because that temp drive is not guaranteed. If that virtual machine reboots, it is going to come up with a different temp drive. So where do we store our data? Well, we store our data pretty much in the same sort of way as we store the operating system. The operating system is stored in a disk, which is, depending on how you've deployed the virtual machine, either 127 gigs in size or 128 gigs in size. So that's your size of your C drive. Just think of it as 127 gigs. It's always 127 gigs, no matter what the pricing page says, no matter what the pricing tool says. Then you have data disks, and this is where you store all of your data. That OS disk and that data disk, they're billed separately from the virtual machine. So while the virtual machine is running, you pay for it on a per minute basis. That includes the cost of Windows Server on a per processor basis. So there's no need for any Windows Server CALs. But your OS disk and your data disk are an additional cost. That's dictated by a number of factors. And they're stored on some back-end storage in Azure. We'll talk about that and the resilience of that as we move on through the session. I said already the virtual machines generation 1, and the data disk, that's where you need to keep all of your data, even for domain controllers. So when you do that DC promo, there's a screen in there we normally go next through, and it specifies where sysfile and the database files and the log files to go. They should be on the data disk if you want to be compliant with the requirements of Active Directory on Azure. So how do we get an SLA for our virtual machines? Well, there is an SLA, and it's in applied in two different circumstances. But what I will say before that is the actual uptime of your virtual machines is extremely high. It's something like 99.95%. So even if you don't qualify for an SLA, you still have very high levels of uptime for your virtual machines. Before we talk about the qualification of the SLA, we have to talk about the concepts of fault domains and update domains. Every rack in Azure is referred to as a fault domain. And the idea here is if we have a localized issue like a top of rack switch failure or a power supply failure, it's going to bring down the entire rack. And ideally, what we want to do is when we deploy services, we'll deploy them onto 2 or more virtual machines so they span these fault domains. So let's say I'm deploying a load balanced web server farm. I have 2 web servers that are going to be load balanced. I'll have one running on fault domain 1 and one running on fault domain 2. How do I tell Azure to do that? Well, I tag those virtual machines with something called an availability set. There's no cost to that. It just means that Azure will take those 2 virtual machines and try to spread them across different fault domains within the cluster. And therefore, if one fault domain goes down, the other one stays up, and one of my web servers stays operational, and my service is operational. We also have these concepts of update domains. Now, when Microsoft are rolling out patches to Azure, they're not doing this at 3 o'clock on a Saturday morning because when you've got millions of hosts, that's just not going to work. What happens is they'll start on a Thursday morning and they'll go until Sunday night. So at some point during the day, you may experience that Hyper-V hosts will go offline. Now, the reality is 2-3 years ago, you definitely would have noticed that because you were probably talking about a typical Hyper-V host taking 10 minutes to reboot. How much of that 10 minutes is the hardware? When I think about it, when I reboot a host, I'm usually clutching onto my chest waiting for that Dell or that HPE logo to appear. That's 2 or 3 minutes right there. And then there's all the SCSI checks and the memory checks and all that stuff that goes on. And then I see the Windows logo, the little spinny thing goes. 30 seconds later, my operating system and my Hyper-V host are up and running. Microsoft have managed to get this warm reboot feature working, which was first shown to us, and actually only really shown to us, or actually it wasn't even shown to us, it was only mentioned during Technical Preview 1 of Windows Server 2016. And that feature never made it to Windows Server 2016 Preview 2. And if you tune into a session by Ben Armstrong from Ignite Australia last January, you'll find out the story behind all that. But Microsoft got this warm reboot working in Azure. And the idea here is they can reboot a Hyper-V host without rebooting the server. So they can make Windows recycle. And that means that recycle can happen in 15 to 30 seconds. So when they reboot a host after patching, we don't necessarily notice it because we're getting to the point where we're almost within the latency period of TCP. So that's pretty cool. But to avoid any potential impact that might even cause us, when we tag virtual machines to be in availability sets, it will also spread the virtual machines across the update domains. So that means Microsoft, when they come in and do a patching cycle, they'll update one update domain at a time, and my virtual machines or my service running on my virtual machines will survive that reboot cycle. Now, how do I get my SLA? Well, the first way is I have 2 or more virtual machines running the same service. I tag them with an availability set. So a pair of domain controllers for the same domain, a pair of load balanced web servers, a database cluster. Well, I can tag those machines as being in the same availability set, and therefore they will get the SLA from Microsoft. And the other way is if I have a single virtual machine and I give it SSD only storage, so no HDD storage, then that virtual machine will qualify for the SLA as well. And those are the 2 mechanisms we can do. But like I said, even without that SLA, we're still experiencing almost that level of uptime that you would get with the SLA. When you start looking at virtual machines, you'll probably start looking at the various different specs and pricing, and you'll be, wow, that's confusing. And I often get asked, how much is a VM in the cloud? And I've gotten to the point where that frustrates me a lot. And I will reply back with, how much is a car? And the answer is anywhere between free for something someone wants to get rid of and $38 million for a Ferrari 250 GTO. And all points in between. Now, more than likely, when you're buying a car, you're not buying on that upper end, you're buying on the lower end. Unless you've done really well in the stock market or something, or you've hit the lottery, in which case, thanks for tuning in. I'm sure you've other things to be doing. But so when we're looking at these virtual machines, it's actually not that different to servers, to be quite honest. When you think about buying a physical server, you know in your head, okay, that server is going to do a particular role. I know what one I want from Dell or HP or Lenovo or whatever. And Azure is very similar. When I think about a particular role, straight away in my head, I know what series of virtual machine I'm talking about. What are these series of virtual machines? Well, think about when you go to Dell and you look on their server sites and you look at their rack servers, you're going to see or 430 or 630 or 730 or 930. Each of those is a series. And within that series, there are different sizes. Go over to HP, DL360, DL380, DL560, etc. And inside of that, there are different sizes when I click on that link in the page. And Azure is the exact same. We have different series of virtual machines. And just like the physical boxes, each of those series have specific traits that make them suitable for certain roles. And when we pick a series, within that series, there are different sizes. Now, that's kind of where the similarity ends. I actually find the Azure side of things much easier because I don't have to worry about component compatibility and stuff like that. But when you're going with the physical box, obviously you have the ability to say, okay, I want this amount of RAM and that amount of CPU, and you can tweak it. The Azure side of things, you pick what's on the menu. This is not Burger King. You cannot have it your way. You have to take what is on the menu. But you can change your virtual machine size as you progress. So you might find that a virtual machine with 4 gigs of RAM is not enough, and you increase it up to 8 gigs. That just takes a reboot, and that's only a few well, not a few seconds, but a minute or two. So you do have that flexibility. I've mentioned the disk size thing. So remember, when you're looking at the pricing tools or pricing pages and you see disk size, that is the temp drive. The C drive is always 127 gigs or 128 gigs. So when we're looking at the names of these virtual machines, there's a couple of characters or letters that specify some specializations for those machines. So if you see an S in the name of the virtual machine, that means that virtual machine supports SSD or premium storage. So high IOPS, low latency, high throughput. If you see an M, it means that machine supports more memory than usual. And if you see an OR, it means that virtual machine, which depending on size can have more than one NIC as a capability, but by default it will have one. But if you see the OR, it means that virtual machine supports RDMA NICs. So it'll have a second NIC that gives you remote direct memory access. These are typically machines that are used for high performance computing, so mad amounts of data transfer, and you're looking for low CPU impact, low latency, high data transfer rates. So let's start off by talking about the virtual machine series that you're most likely to use. So we have the basic A series, and Microsoft described this as being a test dev type machine, good for very low end work. I happen to use this in production. I think it's a great machine for domain controllers in a small medium enterprise market. So the basic A series is once upon a time, it actually used to be a physical Opteron processor in the host, but now it is simulated. And that processor was designed not for horsepower, but more for electrical efficiency. So it was a cost-saving processor. Now this basic A series, it is kind of crippled a little bit, so you don't have any network load balancing. Its data disks are limited to 300 IOPS each, and the temp drive is on HDD. Now, once you start talking about, okay, some serious things like file servers or bigger domain controllers, you're probably looking at the AV2 series. Now, the V2 basically means this is version 2 of that type of series. There was an original standard A series virtual machine, but it has been replaced by the AV2. Slightly better performance and lower cost. That's typically what you're seeing when we see that bump up. So this is kind of the entry-level workhorse, where you're going to see web servers, lightweight app servers and stuff like that. Again, it's that same simulated Opteron processor, but now we do have the network load balancing, and we get the standard speed of HDD storage, which is 500 IOPS, or up to 500 IOPS per data disk. Again, the temp drive is on HDD, and that's the last of the machines where the temp drive is on HDD. All the others, it's going to be on SSD. The DV2 series, which replaced the DV1, higher spec, lower price eventually. D is for disk, and this is for workloads where disk performance is important. And there's a variation of the D called the DSV2 series. I would never deploy the DV2 series. I would always deploy the DSV2 series, because then I have the option of deploying premium disks at a later point if I need to, or convert my standard disks to premium disks. So typically, this is where we see, serious database workloads. Not the small 1 gig database or something like that, but serious database workloads where we need true disk performance. This is based on a Xeon E5 V3 processor. The temp drive is on SSD, and good tip from the SQL Server product group is to move the temp DB onto that temp drive so you have lower latency disk caching. Now, Microsoft in the last week released a DB3 series with a version 4 E5 processor from Intel. And this is 28% cheaper typically than the DV2. And the reason for that is this is the first virtual machine to introduce hyperthreading. So in the other virtual machines like the DV2, every virtual processor is a guaranteed core. But now with the DV3, what we're seeing is Intel hyperthreading. So every 2 virtual processors is a core, and there's threading going on. Now, the DV2 kind of has a cousin called the F series. They're based on the same hardware, the same processor, but there's a slight difference. The DV2, what you're typically going to see is a certain amount of cores and a large amount of RAM, whereas the F series kind of balances things out. So you might have 2 cores and 4 gig of RAM, or 4 cores and 8 gig of RAM. Very familiar sizes. And when I see the F series, what I think of is the pickup truck from Ford. An all-arounder with good horsepower that can do all sorts of things. And it's a bit more grunty than that standard AV2 series. So when I see people wanting to move from the AV2 to run something a bit more powerful on a Xeon processor, it's typically the F series that we start talking about. Then there's some niche virtual machines, which personally I have not seen in production. I've only ever deployed some of these for lab reasons. So the G series, G is for Goliath. That used to be the biggest virtual machine in the cloud with 448 gigs of RAM on the high end. You have the LS series. L is for low latency. The S designates SSD. The unusual thing about this virtual machine is it uses only storage from inside the host. It doesn't use back-end shared storage like all the other virtual machines. That means that virtual machine is tied to that host. But there are certain workloads where that is beneficial because you get that low latency. And Microsoft are recommending this for people who need extreme NoSQL databases. We have the EB3 series, and that is a higher spec set of virtual machines than the DV3 series. So they're basically the DV3s with more cores, more RAM. Then we have the NVIDIA virtual machines. So these are using some features from Windows Server 2016 Hyper-V, where we're able to give discrete access to the physical devices, discrete access to the physical devices to the virtual machines. So the virtual machines aren't using virtual graphics cards, they're using physical graphics processors. So we have the NV series for desktop virtualization, the NC series for compute workloads like simulation, and the ND series where D stands for deep learning or AI. Everyone's trying to avoid saying artificial intelligence because we're all afraid of Chrome robots. But you'll see phrases like machine learning and deep learning, that all basically means AI. Then we have the H series. H is for SAP HANA. That gives you a tip as to what that's for. That's for big OLTP workloads. Sort of thing you typically don't see in small medium enterprise. Then the M series, the new biggie in the block. M is for massive. Up to 128 cores and 2 terabytes of RAM per VM. That's a big virtual machine. And that's why Windows Server 2016 Hyper-V has such high virtual machine capabilities. It is actually because of the M series. Another little tidbit from Ben Armstrong at Ignite Australia. Now, a couple of interesting things about the DV3, the EV3, and the M series. They all run on Windows Server 2016 hosts, so the same Hyper-V we get in Windows Server 2016 when we purchase it. And they all support nested virtualization. So you can run your own Hyper-V farm on the Hyper-V hosts in Azure if you want. Now, I wouldn't recommend that for production systems, but it's great for test, dev, demo, whatever you want to do in that case. The real use case for it is actually something called Hyper-V containers. Now, once you pick a series, you then pick a size. So there's a list of virtual machines you can pick from in each series. So we can see the DSV3 series here. And we can see a D2SV3 has 2 cores, 8 gig of RAM. The tip there is it's a D2, and that means 2 cores. The D4, well, I know it's 4 cores. And without looking at it, the D8, 8 cores, D16, 16 cores. And because I know this series, to figure out what amount of RAM there is, you just multiply the number of cores by 4, and that tells you how many gigs of RAM is there. You can also see that the amount of data disks that are supported goes up as you increase the number of cores, and that's actually so you can handle interrupts. And we see the same with throughput and IOPS as well. So the more IOPS you need and the more throughput you need, you go higher up on the virtual machine series. And again, that's related to the number of interrupts that can be handled by the virtual processors. More cores equals more interrupts. Right, we've talked about disks, so we probably should talk about where to store those disks. And that's going to be on a SAN, right? Because that's where you go when you need scale. Well, the reality is not when you need cloud scale. When you need cloud scale, SAN just is not scalable enough. And in fact, SAN is the most expensive place in the world to get disk. And if you know anything about the cloud, it's probably the cheapest place to get storage. So SAN is not a good fit. Instead, Microsoft used software-defined storage. They've built their own architecture. You can Google and learn about that. It's an interesting white paper if you really want to nerd out on weekend with a whiskey. And, well, one of the benefits for us of that is, A, we get cheap storage in the cloud, and B, we actually get storage spaces and storage spaces direct, which Microsoft have learned an awful lot from the storage side of things in Azure and have been able to share that with us. It's different technology, but they've been able to share that learning with us through Windows Server 2012, 2012 R2, and 2016. Now, this storage is where we're going to put our virtual hard disks for our virtual machines. And we have a few different types of resiliency that we can use. Now, I'm going to tell you up front, from today forward, you should only use the first one, locally redundant storage. And that's where we get 3 copies, 3 synchronous copies of every disk. So if 2 copies are blown up, so 2 different storage systems die, we still have our disk. That's like RAID 10 plus 1, if you want to think of it that way. So it's an additional copy of everything that you get with RAID 10. Now we have the option of deploying geo-redundant storage, which takes LRS and gives us an asynchronous set of copies, another 3 copies, in the paired region. So if I was to deploy a virtual hard disk in North Europe, I would get 3 copies in Dublin and an additional 3 copies in Amsterdam. Or if I was to go with Virginia in East US, I'd get 3 copies of my disk there and another 3 copies of it in the West US. Now I'm only paying for the 3 copies, or the 1 copy in each region, is the way to think of it. So LRS, you don't pay for 3 copies. You pay for 1 copy in LRS. GRS, you're actually paying twice the cost of LRS. So that's the way to think of it. GRS, we used to think of being as a solution for disaster recovery. So if a data center burned down, well, we'd have our disks in another location, and it's literally all we would have. We wouldn't have our networks, our virtual machine metadata, or anything else. We have a different way of doing that now, which is Azure Site Recovery for Azure VMs. So we can replicate our virtual machines and pre-create all the infrastructure for them in another region, in a geo cluster. And in the event of a disaster, we can fail over. So we can do a planned failover in advance of the disaster, like a hurricane, or if it was something like an earthquake, we could do the failover after the disaster. Now, there are different storage types within Azure, and admittedly, this can be quite confusing. I will try to boil this down at the end of the storage section to make it a bit easier for you. but it's worth knowing the different options. When you go in to create storage in the Azure portal, you'll have three options. You have general storage account, cool blob storage account, hot blob storage account. If you're using the storage account method, then you're going to use general storage accounts to store your virtual machines. And you're going to use that storage IO block blob feature to do things like backing up SQL Server from virtual machines to blob storage, to store diagnostics and performance data for virtual machines as well. Disk is where the VHDs are stored, and it has a different billing rate to storage IO. And Azure just knows how to calculate that. You don't have to tell it that you're doing disk storage or storage IO. It just knows what to do for you, and it just does the billing. Now, if you're looking at being able to use a dedicated blob storage account, like if you were using an on-prem backup product to back up to the cloud, that might be a clue as to something interesting is coming up later. Then you can deploy either a cool blob storage account or a hot blob storage account. If you're accessing the blobs less than 2 times per month, cool blob storage is the cheaper option. However, if you're accessing it more frequently than that, then hot blob storage would be the option. Now, coming in the future, Microsoft told us that Build, they will be giving us a single blob storage account that offers tiering between cool and blob, and a new additional archive tier, which will be a lot cheaper. At first, it won't have auto tiering, but down the road, they will offer us auto tiering. Now, when I deploy a virtual hard disk, I can decide if it's standard or premium. In other words, HDD or SSD. If I go with the HDD option, I get up to 500 IOPS per data disk. Now, if I go with premium, I can get up to 7,000 IOPS. Now, you see, I've actually said it's a range between 500 and 7,000. The interesting thing about SSD storage or flash storage is the performance of an individual file is actually dictated by the size of the file. And that's because when you have a bigger file, it's actually writing to more, or reading and writing to and from more cells or NANDs at the same time. So we have more parallelism. So our file in this circumstance is a virtual hard disk. So the bigger the virtual hard disk, the more IOPS it supports. So we can get between 500 on the lower end and 5,000 for the generally available 1023 gig disk, but you can get up to 7,000 with the preview 4 terabyte SSD disk. Bear in mind that premium storage is only available to those virtual machines that have the S designation. So if I was to deploy a DS series of virtual machine or an FS series of virtual machine, I would get that option. If I just deployed a D or an F, I wouldn't have that option. So we always recommend deploying the S, even if you don't need it, because to be quite honest, the virtual machine is the same price. It just gives you the option of adding premium storage after the fact, just in case you need it, or even converting your disks. And a virtual machine can have a mixture of standard and premium. So you might deploy one of those S variant virtual machines with the OS disk on standard storage and the data disk on premium storage, and that way you're managing your costs as well. Now, there are 2 ways we can create these disks. We have unmanaged disks, and this is the legacy method, where I have to create one of those general storage accounts, and then I'll place the disks into that storage account. Now, there's a few catches to that. That storage account offers me up to 20,000 IOPS. So I have to limit the number of disks I put in there before I start hitting a bottleneck. So that's 40 disks, if we're to say that each disk can do up to 500 IOPS. The reality is we can actually get over 500 IOPS at times. So we probably don't want to put 40 in there. Maybe we put 20 or 25 in there, especially when we start looking at some of the optimizations we can turn on. Where if we were looking at premium storage, that's a lot fewer disks we can put in. If I'm putting in 4 1 terabyte drives on premium storage account, that's 4 by 5,000 IOPS, which means I hit the peak of what that storage account can offer. In fact, I probably only put 2 or 3 in there, just in case I turn on some of the enhancements. But then we have another option, managed disks. And this is where we say to Azure, you know what? I don't want to create storage accounts. I don't want to have to manage any of that. Just make life easy for me. I want a disk. I want to call it this, and I want it to be this size, and I want it to be either standard or premium. Azure, you take care of everything else for me. Oh, and by the way, I'll get extra features by doing that. So I get things like the ability to checkpoint individual disks, I get easier template management, and I get extra security features that I can turn on. And because these are now visible as objects the same way as virtual machines are and other things. Whereas the other option with unmanaged disks, they're just files. So it's a lot less manageable. So how do we pick and choose what we're going to do? Well, here's my breakdown. This is my make storage easy with Azure VMs chart. We have two ways we can deploy our disks. They can be unmanaged or they can be managed. And we have two tiers. We have standard storage, we have premium storage. Now you'll notice that 3 of the 4 all have the same pricing mechanism. They all say price based on disk. And you know what? The storage is pretty cheap. So that's, if you're sizing your disk according to your data, that's not bad. But what if you really don't know how much data you're going to need? Or what if you really want to cut the cost down as much as you possibly can? Well, when I'm in that circumstance, I go with standard storage, unmanaged disks. That's where I put the virtual hard disks into a storage account. Because in that case, I'm not charged for the size of the disk, I'm charged for the amount of files in the disk. So now my 126 or 127 gig C drive, well, I'm not being charged for 127 gigs, I'm being charged for the size of Windows, which is what, about 20 gigs, 22 gigs, 2016. If I have a 1 terabyte data drive on a file server and I've only got 200 gigs of data, well, I'm only charged for 200 gigs of data. So I can do some cute things. Or I can also aggregate my disks. So I can create a single volume that spans 8 disks. I may have 8 1 terabyte drives, but only a 200 gig database. I'm charged for 200 gigs of data, but I have the IOPS and the performance of those 8 disks. And I'm taking advantage of storage spaces to make that possible. And this is the slide that talks about that. So an individual disk right now, if it's generally available, has a max size of 1023 gigs, but that doesn't limit the size of the volume, just like a physical disk size on-prem in a server doesn't limit the size of a volume. What you do on-prem is you create a RAID array and a single LUN in that RAID array, and then you format the LUN with a single volume. And we could do something similar in Azure. And what we're doing is we would supply more than one data disk to the virtual machine, and then if it's a Windows virtual machine, log in, set up storage spaces, so we pull the disks together, so we have a single pool of capacity and performance, and from that we create a simple virtual disk. Think of that as being like RAID 0. Now we're not worried about fault tolerance at this level because remember, that's handled at the lower level by Azure, where they give us those 3 copies of our individual disks. So if one misbehaves or dies, we still have 2 more copies. So we have simple virtual disk, and from those 4 disks that are 1023 gigs in size and 500 IOPS, I can create a single volume as 3.99 terabytes in size with up to 20,000 IOPS. So now that's a lot faster than that single disk at 500 IOPS. And I can bump that up even more by turning on caching. So by default, OS disks have no caching. So we shouldn't change that. You should always leave the OS disk with the default caching. But for data disks, have a look what your application recommends. So databases typically will say, yeah, read caching is good. So turn that on. You can bump up those IOPS. I've seen by like 200 IOPS per disk. So if I'm running a 500 IOPS disk, I might get 640, 700 IOPS out of that disk in the right circumstances. If your application recommends it, you also have read-write caching. However, I haven't seen an application that recommends that yet. So how do I connect to my services? Well, ideally, you're talking about a cloud application or a born in the cloud application, and you access that using things like HTTP, HTTPS. If it's a legacy style application with a client, I typically recommend moving the client up into the cloud as well. So presenting that using remote desktop to the end user devices. However, you're probably looking at network connections as well. So we've got VPN, WAN connectivity as well. Things like Windows Server VPN and direct access are actually not supported in Azure, which is unfortunate because I would love to be able to offer those options to some of our customers. That hybrid networking stuff, so VPN and WAN connectivity, is powered by an appliance running on the virtual network called a gateway. And you can have up to 1 gateway for every virtual network that you deploy. That thing will enable point-to-site VPN, which allows admins to VPN in from their desktop or their laptop or their phone or whatever. Site-to-site VPN, which allows a network connection from your office to the virtual network where your virtual machines are running. And that allows you to have flat routing from your client devices on the LAN to your virtual machines running in the cloud. And that's a private encrypted tunnel. And you can do that with fault tolerance as well if you've got multiple internet connections in your office. And then we have the ability to do WAN connections. So let's talk about the site-to-site VPN. There's a couple of options with that. Very quickly, we've policy-based, which allows you a one-to-one connection, and then we've route-based, which is ideal, gives you the most features, the most scale-out, and allows end-to-one connections, or even end-to-M connections. What device or which of those can you support? Well, that depends on what your firewall is. If you do a search for Azure VPN devices on your favorite search engine, Microsoft will give you a list of all the edge devices that they support. So your checkpoints, your Brocades, your Barracudas, your Ciscos, your Sonic Walls, your WatchGuards, all of them listed in there. And you can find even the setup instructions for those firewalls for doing a site-to-site VPN with Azure, and whether they support policy-based or route-based. Watch out, because some big names only give you policy-based, which is really limited. So things like the Cisco ASA only support policy-based VPN to Azure, which is kind of unfortunate. Now, there is a workaround, which is you run a Windows Server VPN on-prem with ORAS, and you use that to do a route-based VPN to Azure. And again, if you go to that Azure VPN devices page, there is a link there to documentation on how to set that up. If you're doing the WAN connection option, which is very expensive, I have to say that, but it gives you the benefit of having much more bandwidth to Azure and an SLA on your network connection. With VPN, Microsoft can't do that because it's really up to your ISP. If you want those benefits, then ExpressRoute is your option. You can do that through an exchange provider, so you get a WAN connection to a data center who then hop you on to Azure, or you go to your MPLS provider and say, listen, I've got 50, 60 sites on my network. I would like to connect all of those to my Azure subscription, and they will. And your Azure subscription basically becomes another site on your MPLS network. Right, there's a lot of stuff there we've talked about, and I've talked about management stuff and how Azure builds on top of Hyper-V to make it more than just Hyper-V, and a big element of that is Azure Resource Manager, or ARM. Imagine you go to a restaurant and you say to the chef, you know what, or to the waiter, excuse me, hey waiter, I would like the chef to go to the fridge. I would like him to remove a pack of steaks. I would like him to take a knife and remove one of the steaks from the pack. I would like him to turn on the grill, put the steak. You don't do that, do you? I haven't done that anyway. What I typically do is I say to the waiter, hey, I would like a steak burned, please, because I like my steaks almost crispy. I can hear people hissing at me now. That's what I do. I want a steak. I would like some fries with that. I'd like some pepper sauce. I don't tell them how to cook it. Now, when you go to a portal or you use PowerShell or whatever, you're actually doing that first approach. You're saying exactly everything you want. And Microsoft learned from this. They had some negative feedback about the early release of Azure, and they said, okay, we actually have to change the API that exists between our tool sets and the back end of Azure. And they came up with something called Azure Resource Manager, or ARM. The idea here is an instruction is sent to the back end of Azure where these resource providers are executing, and it says, this is what the customer wants. And we can write those JSON files ourselves and completely bypass that Azure portal or that PowerShell experience. And we can say, excuse me, Azure, I would like this. Come back to me when it's done. And here's the cool thing about it. It's way, you know how we're supposed to say PowerShell is faster than doing things in the GUI? In Azure, it's not necessarily. It just removes the human element of it once the script is written. JSON is way faster than anything. I can deploy a complex RDP farm, like with domain controller being built up, file server, session host, connection brokers, using a JSON that Microsoft have shared. And it literally takes me about a minute of data entry just to complete a wizard. And then I go away for lunch and come back and everything's running. The RDS farm is built, the session hosts are built, there's a desktop session shared, the domain has been built from nothing, literally, the networks are built, the security and the firewalls are configured, all through that description that's in the JSON. And we can build those ourselves. I used to think this was a developer and large enterprise thing, and I was wrong. I ignored this stuff, and I was wrong. What I learned was this gives us reusable definitions that anyone can use. Whether you're a Microsoft partner doing managed services and you want to give each of your customers, a very similar deployment, whether you just want to learn Azure yourself, you want to be able to build test labs really quickly. Well, if you can get one of these JSON files, and they're shared by Microsoft on GitHub, you can build your own ones from them or from scratch. Well, you can save so much time by just deploying the JSON and then start doing the cool stuff that you want to do with your virtual machines or your whatever it is that you're doing in Azure. Now, the JSON itself, the file has 3 sections. The first bit is parameters, and that's basically a set of questions. What would you like to call the virtual machine? What spec will the virtual machine be? What would you like the admin and the password to be? Then there's variables that can take some of that data and then process it to create more values. So I can say, okay, I'm going to call the virtual machine this, and then variables will go, well, let's call the OS disk, the name of the virtual machine minus OS disk. And the first data disk, name of the virtual machine minus data disk 1. And then that data, parameters and the variables, go into resources where we describe what it is we want. And well, we can take that JSON, hand it over to a junior person, and they can do the deployment. And then the senior person only has to come in, 20 minutes later or an hour later, depending on how complex the JSON was, and then do the serious bits. So the application stuff. So now we can start empowering those junior people to do cool things, and we can optimize how we're spending our time. And we're taking advantage of this at the company I work for. Like I said, we're a distributor, and our customers are Microsoft partners who are all trying to learn Azure right now, and are under pressure to, compete and deliver Azure services. So we've taken that JSON concept, built up a number of solution templates, and we share them through our own CSP portal, which means our customers can sign into that portal, select their customer, pick one of our solutions, answer a few questions like in that picture over on the right-hand side, click add at the bottom, and then 8.5 minutes later, they have a solution deployed, or 12 minutes later, depending on the template. So it makes them competitive and be able to do real cool things with Azure straight away without having to necessarily know how to do all that stuff. There's a learning experience you can go through. This is kind of how I did it, and I've documented all this, and I guess the slides will be shared afterwards. But I basically said, okay, I want to learn this, and the way I did it was I deployed something small in Azure, and then I went and looked at automation script in the settings of that object, and there I could see the JSON that described it. I could download that, edit it in the free tool called VS Code, and then upload it and see what happened. And then I would expand on that JSON over time. So I'd set up a storage account, maybe set up a network, and then add some virtual machines to that, and then do some NAT rules and load balancing rules and stuff like that. And eventually I had myself a solution. And there's a few ways we can deploy that. We can deploy it from the portal, or we can do it using PowerShell as well. Andy.
Hey, good stuff.
So I'm done. Would you like to talk about Altaro VM backup?
I can, real briefly here. I want to leave us a couple of minutes to get to the Q&A because we've had some really great questions. So real quick, if you do have any questions that you haven't asked yet, feel free to use the questions form to do so. One thing I wanted to do real quick, we've been talking about cloud and hybrid cloud, and I find it's always useful to put learning into context with kind of a use case, right? And Aidan and I were actually talking earlier today about what's the low-hanging fruit when it comes to, what's the first thing I move into the public cloud? And offsite backups came to mind. That's often one of the first things that comes to mind when people are looking for workloads to move. And just so happens that we here at Altaro have just completed our first integration with Azure. We now have the ability to vault directly to an Azure storage account. So first off, let me share my screen here real quick. And okay, so I have just another slide or two here. And we recently just came out with version 7.5 of our product, which includes a number of enhancements, one being the Azure piece I'm going to show you here in a second. But we've got a couple of other things that we really focus on with the product too. It's got to be efficient and easy to use. It's got to provide full control of your backups across your environment. And I always like to give praise to our support team. They are fantastic. They do a great job. We don't do tiered support here at Altaro. We on again type of thing. We don't like to have you hold an escalation queues or anything. So when you call Altaro support, you get a product expert that owns your issue from start to finish. And the other thing that's kind of relevant to the cloud discussion is space saving. So we're talking about storing stuff up in the public cloud, but we want that storage to be as efficient as possible. Back in our 7.1 release, we created a new deduplication engine that we've been very happy with. It's done really well when we stacked it up against some of our competitors. And when you use our new Azure integration, you get the benefits of our deduplication, our compression, and our encryption. So I mentioned that we have this Azure integration now. We can send offsite backups directly to block blob storage. You can also do a recovery from that storage to any site that you have that is running our software. So if you have site 1 and site 2, site 1 goes down, you want to recover those VMs from Azure over to site 2, you can do that with our software. And like I said, this is using block blob storage only. You used to be able to do this with our product in Azure, but you had to run a virtual machine with our offsite server software, and you were incurring a monthly compute cost. Now the only cost you have is the cost to actually store it. So let me show you how easy it is to connect to an Azure storage account from our software. So here's our dashboard. I'm already in our backup locations view here. For the sake of time, I'm just going to show you, you can click add offsite location, cloud backup to an Azure storage account, and here it gives you all kind of information about this integration, and you can click this link here that'll walk you through the process of creating a storage account in Azure. And when you're done with that process, you'll get a connection string. You take that connection string, it's just a long, weird looking string of text, you paste it in here, and that allows our software to talk with the necessary APIs over in Azure to move that software, those backups directly into the Azure storage account. So it's very easy. Once you've done that, it'll appear in your list here on the right, and you can assign virtual machines, take your offsites, and go. So it's very, very easy to set that up. Not hard at all. So with that said, I want to leave a couple minutes for the Q&A. So like I said, if you have questions that you haven't asked yet, feel free to ask them. I see we've got quite a few here. So I've been asked a couple of times if the slide deck and the recording will be available afterwards. Yes, we'll be putting out a blog post containing both of those in the next week or two, and you'll get an email regarding that. But we had a couple of good questions here. And the first one that I wanted to touch on really centered around the whole warm reboot idea that you were talking about, Aidan. And basically how the virtual machines don't get rebooted in that sense. That really looks like what the question is about. When the host does a warm reboot, what happens to the virtual machines running on it? Can you go into a little bit more detail about that?
Yeah, Microsoft call this in-place migration, which I think is a bit of a misnomer. What really happens is the virtual machine is stopped, so it's a clean stop, and the host reboots and the virtual machine starts up again. So that's what it is. The virtual machine doesn't magically stay executing, as far as I know. And they do tell us that we should expect 15 to 30 seconds of downtime when it goes through this. The reality is it's fast enough that it's not really noticeable with an internet-based service. If that is a problem for you, then you should be looking at deploying out, born in the cloud services that can take advantage of availability sets and run across multiple update domains and fault domains.
All right, thanks, Aidan. This next question is one that I've actually run into myself before. So the question is there a way to keep track of the availability of the different series VMs across regions? So I mean, right now, if I want to see if an NV series is available in the central US, I actually have to go through the deployment process and see if it's made available to me during that wizard. Is there like a way, or is it documented somewhere where I can go see that, hey, these series are available in these regions, these series are available in these regions, et cetera, et cetera?
Yeah, you can be insane like me and subscribe to several hundred blogs and tweeters. The more efficient way is if you do a search online for Azure regions, And that will bring you to the Azure regions page, which lists all of the various different Azure regions. And up in the top left-hand side, I think it's a big blue button, and it's something like check service availability. When you go to that, you can select which of the geographic clusters you're interested in, whether it's North America, Europe, whatever. And what that does is it's a matrix of all of the regions and all of the services. So if you're interested in, running an M series virtual machine or an LS series virtual machine, or like you said in the question, an NV6, then you can see whether that's available in your region or not, or what regions it is actually available in. So that's kind of how you do it.
All right, good deal. That'll be a good page for the bookmarks. So I think we got time for one other question here. And again, any questions that we didn't get to today, we will definitely cover in the follow-up post out on the Altaro blog. But the last question I want to cover here is around managed and unmanaged storage. Is it possible after I've deployed the workload? Is it possible to change back and forth from managed to unmanaged? My gut says no, but just want to clarify.
You can definitely go from unmanaged to managed.
Ah, okay, good.
Yeah, so that's actually pretty easy. It's 2 PowerShell commandlets. I've documented it on petri.com, and Microsoft's documentation on docs.microsoft.com for Azure is actually excellent. Can't say that for most of Microsoft, as you know, but the Azure documentation is excellent. And it's 2 commandlets. So the first would stop the virtual machine, and the second one does the conversion and automatically boots the virtual machine back up once the conversion's done. It takes, actually, the most of the process is waiting for the virtual machine to boot up, to be quite honest, and the conversion process is very quick. That's probably dictated by the size of disk that you're talking about. But I have found it in my testing to be quite quick.
All right, well, good deal. Well, I think that about wraps it up for us. I want to be respectful of everyone's time. So first off, thanks, Aidan, for joining us today and teaching us all about Azure. It was a lot of great content, so thank you, my friend.
Thanks for inviting me.
Not a problem. Always happy to have you. And then I want to say thanks to all the attendees for attending today. Hope you found real value in this. And then, like I said, be sure to check out our follow-up blog post out at altaro.com/hyper-v. And if you want to sign up to receive email updates, you can do that at altaro.com/hyper-v/signup. So with that, I will leave everyone and hope you have a great day. And thanks for watching.